Math 1, Practice 2.2.2, Solving Systems of Linear Equations. So remember, when we're solving a linear, or a system is two or more inequalities. Okay, to graph a linear inequality, first we graph the line. Okay, then we check to see if it's inclusive, so it's a solid line, less than or equal to or greater than or equal to, or non-inclusive, which would be just less than or greater than, and it would be a dashed line. And then we decide which side to shade, okay, using a test point. So test point and shade. So with a system, then we're just doing it with more than one inequality, and we find where they overlap in their shading. Okay, so that's kind of the extra piece where they overlap in shading is the answer. Okay, so let's start with the first one. So y is greater than x. So think of that as y equals x. Well, there's no y-intercept, so our y-intercept would be at 0. Our slope is 1 over 1, so we go up 1 to the right 1, up 1 to the right, up 1 to the right, and so on. Okay, so I just get my doubts. And we could also go back the other way, as far as we need to. Then we look, there's no line underneath, so I know it's going to be a dashed line here. Okay, then we do a test point. So this says y is greater than x, so wherever y is bigger than x is probably going to be where we shade. So let's pick this point 4, 0. 4 for x, 0 for y. Is 0 greater than 4? Nope. So we shade this opposite side. Okay, there's the first inequality. Now we do the same process for the second one. Once again, plus 0, so we have a y-intercept right there at 0. Negative 1 over 1 means we go down 1 to the right 1. So just the same type of pattern, just the opposite direction. Okay, no line under it, so it's also dashed. So basically, remember, that means that the lines do not have an answer to them. Okay, now which side do we shade? Let's try 4, 0 again. So 0 for y, negative, and then a negative x, so it would be negative 4 instead of positive 4. Is 0 greater? Yeah. So we shade that side. Now we look where are both sides overlapped. It would be right in this section, okay? And so that's our solution, okay? If I take a point and I put it in here, in this empty area, that's not going to be a solution for any of our inequalities. If I put a point over here in just the blue or just the red, that's a solution for just one. Okay, this is a solution for our second, for y is greater than negative x. This one's no solution. And this one's a solution only for y is greater than x. It's only here in this purple zone that we have a solution for both. And that's what we're looking for. The one that satisfies both. Okay? Alright, let's just keep on trucking. Number 2. So, we've got basically the same thing. So they'd be the same lines. So blue was going this way. It's y-intercept. Down 1 to the right 1. Or up 1 to the left 1. Now this time it is a line. So that line is part of the answer. And if we check that same point, 4, 0, so 0 for y, is 0 greater than negative 4? Yep. So that's the side we shade again. Okay. Now we take a look at this other one, and we had a y-intercept at 1, and then it went up 1 to the right 1, or down 1 to the left 1. Okay, once again there's a line under there, so I draw a solid line this time. Pick my test point 4, 0. 0 for y is 0 less than or equal to 4. Yes, that is true, so we shade that side again, so it's actually shading this side. Okay, so which side do they share? The shading. It's this fourth of the piece. Now remember, this zone in here, it's not a solution to either one of these. If I picked a point anywhere in this zone, it wouldn't work for either one. If I went to this zone and picked a point, it would work for our bottom one, but not for the top one. If I picked a point in this zone, it would work for the top, not for the bottom. Only in here is it an answer, a solution for both of them. Okay? Alright. Let's keep going. Okay, so the top one, we have negative 4 for y-intercept and the slope of x, so up 1 over 1. Okay, kind of that same pattern. Now there's no line underneath there, right? Right there. So we know it's going to be a dotted line. So I draw my dotted line. Now I can pick my test point 0, 0. 0 for y, 0 for x. Is 0 greater than or equal to 0 minus 4? So 0 would be greater than negative 4. It is, so I shade this way. Notice how I do my lines, because we're going to be overlapping. Just kind of an easier way to do it. Alright, now the next, positive 10. There's my y-intercept. Positive 2x, so normally I'd go up 2 to the right 1, but I can also go down 2 into the left 1. So I go down 2 to the left 1 for each point. Now, looks like our graph's not going to cross. It will eventually, but for now, no line under there. So I draw a dashed line. Okay, pick my test point 0, 0. 0 for y, so is 0 less than 2 times 0 plus 10. Well, 2 times 0 is 0. 0 plus 10 would give me 10. Is 0 less than 10? It is, so I shade that way. Okay, so that zone that's going to be shaded by both is in between them, isn't it? So that's where our answer is. Okay. Alright, number 4. Okay, so looking at these, number 4, positive 4 for y-intercept, go up to 4. Negative 3, so that's like negative 3 over 1, so I go down 3, 1, 2, 3 to the right 1. That's my pattern. So down 3 to the right 1. And I just keep that pattern going. Or I can go up 3 to the left 1. Notice on both of these there's no equal to, so that tells us that. It's a dotted line again, or dashed, however you want to say it. Pick our test point 0, 0, 0 for y, negative 3 times 0 plus 4. So 0 plus 4 would give us, not 0, give us 4. So is 0 greater than 4? Nope, so we shade the opposite side. Okay? Now we do the next one. Okay, negative 10, so we start at negative 10. Slope of 1 over 1, so up 1 to the right 1. So follow that pattern. We already said it was non-inclusive, so we do a dotted line. Don't know what happened up there. Then pick our test point 0, 0. 0 for y, 0 for x. 0 minus 10 is negative 10. Is 0 greater than negative 10? It is, so we shade this side. So you can probably see where they overlap, which would be right in this zone. And that's our answer. Now, if we look at number 5, it might freak us out a little bit because there's 4 of them. That's all right. Okay? The easiest ones to start off with are going to be these two guys because they only have one variable. When you just have x is greater than or equal to 0, that means x is the x-axis, so 0 for x would be right here. So I make a horizontal line. Now it's a solid line, not dashed, because we've got the equal to. All four of these ones are. Now the x equals 0, and now x is greater than that. Is x going to be greater if I go to the right or to the left? Well, as I go to the right. So that's how I shade. Okay? Then we do y is greater than 0. So y is this axis, so 0 for y is right here. So I draw a horizontal line. And then y is greater, which would be up, not down. So I shade this zone. Okay, so between these two, we're just in the first quadrant, aren't we? Now I look at 0 plus y. X plus y is greater than or equal to 0. Okay, so we could solve that in slope-intercept form way, and we'd subtract x from both sides. From x plus y is greater than or equal to 0. So I'd get just y is greater than or equal to a negative x. So we've done that one before, right? That negative x. So a y-intercept of 0, and then a slope of negative 1 over 1. So basically, like this. Okay? And that tells me, then I plug in a test point. Let's do 1, 1 here. So 1 for x, 1 for y, 1 plus 1 is 2. Is 2 greater than or equal to 0? It is, so we're shading this zone again. Okay? Didn't really affect our answer a whole lot. Okay, now the last one. Now this one I'll remind you how to do it in the x and y intercept form. So to find the x-intercept, we make the y 0, divide by 3, because adding 0 does nothing, and we're left with x is less than or equal to 1. Okay, so our x-intercept is at 1. Now, we should probably do this one a different color, huh? Now to find our y-intercept, you make the x-intercept 0, or the x 0, so 3 times 0 plus y is less than or equal to 3. That becomes 0. 0 plus y is just y, so we get 3. So I go up to 3. Okay, and draw that point. Now we know it's inclusive, so I draw my line based off that. Then we pick that test point 0, 0. We can go back to the original for that one. So 0 for x, 0 for y is going to make it 0, right? Because 3 times 0 is 0. 0 plus 0 is 0. So is 0 less than 3? That's true. So I shade to the left. So now what's the only spot where they're all going to be shaded? It is this little itsy bitsy triangle right there. That is our solution. Very small possible answers. Okay? Alright. So number 6 kind of starts off the same, doesn't it? Y is greater than 0. So we knew that that was a horizontal line, and that y is bigger, so it goes up that direction. Okay? X is less than 5 means we go to 5, and we draw a solid line here. X is less, which means it goes to the left. Okay, so far only that zone is a solution. So we can pretty much rule out all these other 3. Okay, so equal to, equal to, equal to, not equal to. So that one's going to be dotted, the rest are solid. Now let's figure out this one. Okay, so we can use the x and y intercepts for these. So 2 times 0 minus y is greater than or equal to 2. Okay, so that would be 0. Negative y is greater than or equal to 2. Divide by negative 1. Remember, in equalities, when you divide by a negative 1, you swap it. So y is less than negative 2. So negative 2 is the y-intercept, not the x-intercept. Don't screw it up like I just almost did. Then we do the opposite. So we have 2x minus 0 is greater than 2. So that would eliminate that, leaving us with 2x is greater than or equal to 2. So divide by 2, and we get x is greater than or equal to 1. So x-intercept of 1. then we draw our line there. Okay, pick our test point, which I'll pick 0, 0 again, because that's the easiest. 0 for x, 0 for y. Is 0 greater than or equal to 2? Nope. So I shade this way. Okay, so now we can see that this little triangle here is really the only zone as of right now. Then we do one more. So 2x minus y is greater than 0. So if I make x 0 to find the y-intercept, I get y is greater than 0. Okay? So it would be right there. So my x-intercept is going to be the same thing, so that doesn't help us, right? That's why it's a good idea to know how to change these to slope-intercept form. So I'd subtract 2x from both sides, giving me negative y is greater than negative 2x, divide by negative 1, and I get y is less than, because we have to flip the inequality, positive 2x. So my slope is 2 over 1. So up 2 to the right 1. Or down 2 to the left 1. Okay, this one is a dashed line or dotted. Okay, but it doesn't really seem to help us figure this out, right? We can't pick the test point 0, 0, so let's go 1, negative 1. So negative 1 for x, so 2 times negative 1, minus positive 1 for y is greater than 0. So negative 2 minus 1 is negative 3. Is negative 3 greater than 0? No. So we shade this way. So with all of those together, we still realize that this is our all-time shaded on everything zone. Okay? So that's our answer. Alright, now I think we got one more of these. Okay, so once again, we start out pretty simple. Y is less than 0, so on the x-axis we're going below because y is less than. Okay, then x is greater than 0, so here, and we go this way because it's greater. Then x minus y is less than or equal to 7. So if we made x 0, we'd have a negative y, divide by negative 1, we get negative 7. So our y-intercept is down here at negative 7. Now, if we flip it and make the y 0, then we're left with x and 7. So positive 7 would be x. It's equal to, so we draw a solid line here. Pick our test point 0, 0. 0 for x, 0 for y, 0 minus 0 is 0. Is 0 less than 7? It is, so we're shading that way. So you can see that triangle already starting to form. Now let's see how the last one. X plus y is less than 7. Let's turn this into x slope-intercept. We get y is less than or equal to negative x plus 7. So we start up here at 7. Slope of negative 1 over 1. So down 1 to the right 1. And it's solid. So we draw our solid line. Pick our test point 0, 0. 0 plus 0 is 0. Is 0 less than or equal to 7? It is. So I shade that same side. So once again, that triangle is where everything overlaps, isn't it? Kind of tough to tell, though, on these. So there we go. Alright, now 8, 9, and 10, we are going to do some more graphing probably. So let's make a graph here for them. So here's our graph. So 8. A school supply company produces wooden rulers and plastic rulers. It takes 30 minutes to cut, shape, and sand a wooden ruler. It takes 15 minutes to mold, dry, and cut a plastic ruler. There is a maximum amount of 480 minutes per day set aside for these tasks. Okay, it takes 6 minutes to paint the lines and numbers on both types of rulers. There's a maximum of amount of 180 minutes per day set aside for this task. So we've got wooden rulers and plastic rulers. Wooden we'll just call X, plastic we'll call Y. So 15 minutes times the number of plastic ones we make, so Y, 15 times Y, plus the 30 minutes for the wooden, which is X, 30 times X, has to be less than or equal to 480, because we have that maximum. So here's one inequality. The second one, it takes 6 minutes for both of them, so 6 for the X, 6 for the Y, which means we have 180 minutes, so that has to be less than or equal to 180. So there's our two inequalities. So basically we're trying to figure out how many wooden and plastic rulers, what different possibilities are there to make. Okay, so we need to graph them both. So we have 6x plus 6y equals 180, or not equals, is less than or equal to 180. We also have 30x plus 15y is less than or equal to 480. Now these numbers are going to be bigger than my graph. Okay, so the best thing for this is to use some technology. So jump over to Desmos, type these in, and let's see what we get. Alright, so here it would be graphed. Now the red line goes from 30 to 30, because 180 divided by 6 would be 30, okay, for each the X and the Y intercept. So, and it's shaded down because we're not making more. Now, it wouldn't make sense to go beyond the X and the Y axis, because that would mean you're making, the X stands for the wooden rulers, the Y, or no, X is the, wooden rulers, and Y is the plastic ones. So it wouldn't make sense to make a negative amount. You can't make a negative amount. Now the blue line is 30x plus 15y, so you've got its X and Y intercept. So they both shade down, so within this zone right here would be the number of rulers or things you could make. So like you could make 10 of each, and that would work. You could make 20 of one and like 6 of another. So all these points represent those possibilities to not use up too much time. Okay? So once again, that Desmos works great, especially with these that are really big. Okay, let's take a look at the next one. 9. A bicycle shop sells road bikes and town cruisers. It takes 2 hours to assemble a road bike, so road bike we'll call X. It takes 1 hour to assemble a town cruiser, we'll call Y. There's a maximum of 60 hours to complete the assembly for the week, so 2 times the road bikes plus 1 times the town cruisers has to be less than or equal to 60 hours. After assembly, for safety reasons, the assembly needs to be checked and tested. It takes a half hour to check and test the road bikes. So the road bikes are half an hour, we'll call that 0.5x, plus a quarter of an hour, we'll call that 0.25y, to check and test the town cruisers. There's a maximum of 20 hours, so less than or equal to 20, to complete these tasks. Here's our system of inequalities. Now, let's throw it onto Desmos again, because that's going to be the easiest way to do these. Makes it a lot quicker and a lot easier. So we'll take a look at it right here. Now this one's really interesting because notice that the red is below the blue. Okay, so pretty much anywhere the red is, once again going beyond the X and Y axes would make sense. Okay, so we're confined to basically just the red, which the red one was the 2x plus 1, y is less than or equal to 60. So that's making them. So the safety inspections, you actually have a little bit more time. Okay, so you could actually inspect more bikes here than you can actually make, which means you'd probably have to use that, maybe spend a little bit more time checking them. Okay, but there's that one. So taking a look at the last one, Jana is a caterer. She's making lasagna cupcakes and gorgonzola onion tarts for a party, and only has a limited time to finish, obviously. She already has all her fillings ready and just needs to assemble and bake the appetizers. Okay, so we've got the lasagna cupcakes and gorgonzola onion. Call that Y, we'll call that X. Takes 10 minutes to assemble each lasagna, so 10 times X. For gorgonzola, it takes 15 minutes plus 15Y, and that's 2 hours, so less than or equal to. Now, We could put 2 hours, but notice that these are all in minutes. So why don't we change it to minutes? So 2 hours would be 120 minutes. Then to bake, lasagna take 20, so 20 times x, plus gorgonzola takes 6, so 6 times y, and it's going to be less than or equal to 60. So once again, let's head over to Desmos and get that graphed for us. Okay, now looking at this, this is how long it takes to assemble them, and this is how long to bake. So that baking really limits what we can do, doesn't it? Okay, here's a small section that only deals with baking. So once again, all the amounts of things up here are going to take too long to make or bake. So there's no solutions in this zone. Okay, she could assemble these ones over here in any of these quantities, these points, but they would take too long to bake. So it works for one, but not for both. Same with this. She could make some over here where it would take too long to make, but baking would work. Okay, so the only possibility for everything, because she can't make negatives, is this zone right here. And that's the solution. She can pick any of those amounts in here, any of these x and y points, to figure out how many she should make. And there we go, guys.